The second dot point for MM4 area and volume says calculate areas for annuluses or annuluses and parts of a circle, so quadrants and sectors, etc., and using appropriate formula. So the formula for the area of an annulus is this one here. So for example 3, calculate the area between two circles, which gives us an annulus. We are finding the area between the green circle and the pink circle. So this area in here, which is kind of like a donut shape. So using the formula above here, we've got pi times the green circle squared, the radius of the green circle squared, minus the radius of the pink circle squared. So the radius for the green circle, 1, 2, 3, 4, 5 units. Pink circle is 2 units. So we have pi times, in brackets, brackets are very important here, 5 squared minus 2 squared, which gives us 66.0. When you actually do this calculation, you'll get 65.973, etc. And when we round to 1 decimal point, the 7 makes the 5.9 part go up to 6.0. So we get 66.0. So the area of the annulus, or annulus, some people like to say, is 66.0 square units to 1 decimal point. So make sure you do that 1 decimal place. The other way to do the problem, it's always good to have two ways to do problems, is you can find the area of the large circle, the area of the small circle, and then find the difference between them. And you can see that we actually get exactly the same answer. Just make sure if you do it this way, if you're using a progress area, a progress number, that you use more than the required decimal places. Otherwise, you might get an error in your measurements, in your calculations. Example 4 says find the area of the shaded sector. So you can see here that we have this shape here. So we've got 3/4 of a full circle. So 3/4 times pi times 1 squared. So we've got theta over 360, or we can use the fraction. And the radius here is 1 unit. So 3/4 times pi times 1 squared, which gives us approximately 2.356 square units, which we can round to 2.4. So if we use theta over 360, this angle would actually be 270. For example 5, find the area of the shaded sector. So we need this angle here. This time we don't have a nice fraction, we have 235.49 over 360. So this fraction times pi times the radius squared, and the radius you can see here is 2 units. And we get approximately 8.220, which we can round to 8.2 square units. I like to put in this line just to show that I've done the calculation correctly, and then round to make sure that you round. In this case, it didn't actually ask for it, but it's always a good idea to round when you have this many decimals. 1 decimal place, if you get to choose if the question doesn't state the required accuracy. So 1 or 2 decimal places is pretty normal.